Let's go to League 2345. Find the number of visible mountains. For this question, it gives us two-dimensional array peaks. And for every element peak um, that has xi and yi in it, which represent the peak of this kind of mountain, right? So it has a coordinate xi, yi. And you see that a mountain can be described as a rectangle isolate triangle. So that means this one is 90 degree, right? So this is y, yi, and this is xi, right? So the things that for this kind of rectangle triangle, we know this length, right, is also yi. This length is yi. So we know the left intersector of this mountain is xi minus yi, and the right interceptor is xi plus yi. It asks how many visible mountain. Let us to count how many mountains are visible. So a mountain is considered visible if its peak does not within another mountain, include the border of another mountain, right? So that means that we'll say, for example, this kind of mountain, right? This is A, and there is, for example, B, right? So this one count as 1 because B is not visible. And if we have, for example, A is here, right? B is here, then this will be counted as 2, right? And it have a special case that is the mountain, they have the same shape, right? For example, another one is also here, right? Then, just like the example 2, we'll consider this as 0 because everyone being covered by each other. So this will be considered 0, right? So we need to consider these kind of 3 cases. But this one is not counted as 1. So what we need is handle this kind of things when we find a mountain, we cannot count the result instantly, right? Promptly. We need to consider whether the next will cover current one. So we know that for the right angle, this kind of angle, right? So the mountain is actually can be described as intervals, right? Just a left interceptor and a right interceptors. Because we don't need to think about mountain, we can just think about the intervals. So if this case, right, we count as 2, and if this case we count as 1, and if we have intervals, they share the same start and end, right? So that start is the left interceptor, and end is the right interceptor, that is 0. So we just consider these 3 cases to count how many, to count the result. So that's it, so that we need to sort the left, right? Left first in an ascending order. And when we sort the left, we need to sort the we can sort the end in a descending order, right? Because that means that because the bigger one, right, can cover the smaller one. And if this is in ascending one, right? If this is ascending one, if this is X anyone, right, we cannot compare this one with this one to see whether it is a new variable or not, right? So, so this is like so we need to sort this one in ascending order and this in a descending order. So the reason you see, if we have this in ascending as well, right? And this one covers both this, right? But we only compare this one with the previous one. We said we actually this cannot count as a new visible mountain, right? So that means if we sort this kind of things in ascending order, this will compare with um this, right? And you'll see this will be covered, let's say by 1, 2, 3, right? So 2 will be covered by 1, so will not count a new result. But the thing is that if we sort as 1, 3, 2, right? Then 2 will be compared with 3, and that will get a mistake result, wrong result, right? So our interval starts in an ascending order. The end will be a descending order. So we need a have this kind of sorting, right? So let's write the code sort array sort peaks, and we can have a comparator dot comparing int, and we need to have p the left interceptor, right? Minus p1, and we'll write then comparing int. So we can have parentheses here. So it will be the right will be the descending order, right? So the descending order we can have actually we can have a minus the p0 plus p1. Okay. So this will be how we sort those kind of intervals or mountains, right? So we are going to have in A equals peaks dot length and the result equal to 0, right? So what we do is that we need a pre variable called pre, which is represent the previous right intercept. So what we do is that for int I equals 0, I smaller than n, I plus plus, then we're going to have a current peak equals peaks I. So what we do is that, well, trying to see its right intercept, right? Peak 0 plus peak 1. So only when current right intercept is greater than previous one, right? Then we are update the pre equals current. But the thing is that we need to check whether this even for example, we have this one being greater than previous one, right? We cannot count this as a number at instantly, right? We need to compare, trying to see the next one, right? Next one will be whether it will be the same. So only when if the same, right, we should continue the counts. So what we do is that if I smaller than n minus 1 and x I 0 equals px I plus 1 0 and px I 1 equals peaks I plus 1, 1. In this case, we need to continue. We cannot count, right? And otherwise, we just have a result increased by 1. In the end, return result. And the Python code will be very similar. Let's write the Python code as well. So we know we need to have the peaks sort, right? Sort we can have a key equals lambda peak. So we'll first use a left interceptor. Then we'll sort by the reverse order of the right interceptor. So this will be the sort, right? So we'll have a result pre goes length 6 and result will be 0, pre equals 0, right? So for I in range, and what we need is that we're going to have a peak equals peaks I. So we'll have current right intercept will be peak 0 plus peak 1. And so let's say if current right interceptor is greater than the previous right interceptor, I have previous interceptor, right interceptor equals current one, right? And we'll see if current this one is smaller than -1 will be covered by the later one, right? So if peaks I equals peaks I plus 1, right? In Python, we can use the equal to compare the array. But in Java, prefer do not use that because sometimes if you use capital interval, right? Capital it will compare the references. It's easy to make a mistake. So we say continue. Otherwise, we just result plus equal to 1. In the end, we just return result. Invalid peaks sort key equals lambda. This error should not have a comma here. Local result is not associated value. Result, this will be result. Do you like this? We have a sort, right? Sort, so it will be n log n time complexity and a constant space complexity.